Welcome again. Now we have the two next topics of the point-to-point and shared media. Point-to-point and shared media describes how is your devices connected together and how are they negotiating or are they contacting each other. How are your devices contacting each other depending on the network they are connected to. So it's either a point-to-point or a shared media. Point-to-point, it is the method of directly connected and nothing in the way, just like I have a single computer directly connected to another computer. This doesn't just depend on the having just an Ethernet cable or whatever type of cables are connected directly between the two cables. This is the type of media, the type of connection. This doesn't just depends on a physical component that you can see by your eyes and I'm just connecting or injecting a cable from each side, then that's it. This is a point-to-point. No. If you remember when we described the WAN topology, the first type was a point-to-point WAN topology, where in this type you had like several networks in the way, but your router can see and communicate with the opposite router of another company, or maybe it's your router also, but in another geographical spot, in a matter of point-to-point using some protocols. So this is the concept of point-to-point networking. The other type is the shared media, where you have broadcast. Whenever you have broadcast, or whenever you have a layer 2 device, by this I mean the switch, then this will 100% create a broadcast domain and create a shared media. Switches do behave like sharing everything with everyone in touch or in contact with the switch. Switches do not separate each port from the other. They do give a shared media for everything to have a collision with every other thing, and we will come in details to this up next. Okay. Next topic, we have power over Ethernet, which is known as PoE. You remember when we needed to carry only 100 megabit per second in the Ethernet twisted pair, we had to use only 2 pairs. Okay, so you know in total there were only 4 pairs, so we would have another extra 2 pairs. And we did mention, if you watch or in case you have watched the previous chapters or lectures, we did mention that the other 2 pairs, the other 4 copper cables, will be to carry power. Okay, this is enough to power enough in these 2 pairs to power up some network devices, like what is called an IP phone. Some calls it extensions, or to carry it, or to power up, I'm sorry, with some printers, your house DSL modem, some type of cameras that is called an IP camera. Okay, because it's connected, you can connect to this camera an Ethernet cable to carry the data of the video also alongside with the power. It can completely replace an AC adapter, so this will minimize a lot of the disruption of cables, because like you have maybe you have this wall or you have this room, and whenever there is a camera, okay, that is watching, these are cameras, excuse me, these are cameras, okay, and another cameras and everywhere. So for each camera you have to reach 2 types of cables. The first one for power, and it ends up with an AC adapter that is plugged in the electricity, okay, source, and the other one is to carry a power and is connected to what is called the DVR. Okay, PoE can replace these 2 with only one single power cable, connected to a cabinet, so it can carry both the data and the power to power up this camera and transmit the data, the video or the picture, the data. Okay, So this is the benefit of the PoE. This can minimize a lot of cables and a lot of disruption and chaos in your network environment just by eliminating half the number of the cables that you need to power up and transmit data between some devices and the sources. Okay, we have just talked about these lines. Power of Ethernet terms. We have two terms in the power over Ethernet. The first one is the power sourcing equipment. Who is the device that is sourcing the power and sending this power, providing or feeding this power to the IP phone, IP camera, or whatever device we have talked about. This is like either switches or power injectors that you have in the power source. And the second term is power devices, the consumers who make use of PoE, like PCs, IP phones, IP cameras, some printers, and etc. some other devices. Okay, there is a negotiation of the amount of wattage, the watt, that is needed for the device to power up between the equipment and the device before and even after starting supplying. So first, the PSE, the provider, will start sending a power of like maybe 1, 2, even 3 watts to the power device, to the like the IP phone, and there is an electrical circuit will be established between them and an electrical field. They will negotiate each other that he will send the first device will send like 3 watts to the other device. If it was enough, it will reply it with this one that 3 watt is enough. If it was not, that it will reply that it will need more. Maybe it need a power up to 15 watt for this IP phone to function properly, maybe 6, 9 watts, that depends on the model and the functions of this IP phone. Maybe it has an LED screen, maybe it has only a digital simple screen, maybe it comes without even a screen. It depends on the type of the camera, the phone, or whatever the PD type is. Okay, power supplying over PoE can be from 15 up to 95 watts, but this is a total. What I mean is that if a switch of Cisco switches is supportive for PoE and it has like 24 ports, okay, how much are these? 9, 18 ports. There's no switch with 18 ports, I think. Okay, let's assume these are 24 ports. Okay, and this switch is supportive for power over Ethernet, so it do supply data and power for each port of its 24 ports, but the maximum maybe of this model is 95 watt. So you have to divide these 95 watts on all these 24 ports, or maybe on only the first 6 or 9 ports that are going to some PDs, so some power devices, and you have to divide the 95 watt between them, okay, or manage it between them and leave the other ports with no power, only with data. You can do this. Okay, lastly, we have a new technology developed from the PoE, which is called the Universal Power over Ethernet Plus. This makes use of all the 4 pairs of the 4 pairs, okay, the 8 cables of the copper cable of the twisted pair to carry both data and power simultaneously between these 4 pairs, between the 8 copper cables, not isolate the 4 copper from the 4 data cables from the 4 power cables. Okay, this is for the power over Ethernet. Next, we have the interfaces and cable issues. Some common issues that you might face when you are using Ethernet cables mostly. The first one is collision. Collision happens where more than one device is transmitting, sending information at a single time in, what is this? What causes shared media on broadcast? Using switches in a shared media. Okay, so when I have previously, one of the first devices developed in networking was called a hub. Let's see if we can do this in specific. Good. Okay, because it has only one single arrow as a symbol. Its name was a hub device. Hubs were connect more than a single device at a time. They look and function almost like a switch, but there will be a big difference if we discuss it in the upcoming lectures. What happens is that this is PC 1, 2, 3, 4, and 5. If the first device wanted to communicate with the third device, this is the only connection and transmitting that will be established at that time. Only device 1 can talk to 3, the others can make no use of the shared media between them, of the hub that's connecting them, because in case device 5 wanted to talk to device 2, in here there something will happen which is called collision. Okay, data will collide and PC5 and 2 will have no idea that their data had a collision. PC5 precisely will have no idea that the file or the data sent from it had collision and dropped and it did not reach device 2. Okay, because device 1 and 3 are transmitting at that time. This is collision that used to happen in the hub environment. What happened is that a new technology developed called carrier sense multiple access over the collision detection. It used to detect collision. Its name was CCNA over CD, and that was developed with switches. Is that what will happen when a device wants to talk to another device and the third wanted to talk to the fourth? There is a collision detection will happen between them, and the switch will separate each collision in a different layer, so no collision will happen. All devices will be able to talk to all devices at the same time with no problem and no collision. That is thanks to the CCNA over CD. Next, we have errors in case you had some physical or layer 1 physical errors shown in your switch or router while you are using them. So it's either to be a cabling issue in the copper cable. Maybe your RJ45 is not inserted correctly. Maybe it's not cabled correctly upon the Ethernet copper cables. Maybe you have some problems with the twisted pair. They are not matching on the ends of the sizes. This depends on the cabling type. Okay, in the SFP, in the optical fiber world, in this type of cabling, maybe the type of SFP is not supported on this device. Maybe the cables are injected in reverse on the other end. Maybe it should be reversed again so it can operate. This is what you can solve, or you can maybe guess when you have the errors message on your device. Duplex mismatch. Devices used or cables used to transmit in half duplex or full duplex. Half duplex is a shared media where you can only send at a time without receiving a feedback from the device at the same time that you are sending. I mean, device 1 and 3, device 1 is sending an email to device 3, but he cannot receive, maybe an accident or just a coincidence, that at the same time device 3 is sending an image or a photo or text to device 1 by the time that device 1 is sending the email. This is not applicable in half duplex. Half duplex only supports single media, either transmitting or receiving at the same time. Full duplex do support to send and receive at the same time. Duplex mismatch is like you have connected this switch to this router using a certain cable. Okay, what you have configured, this is only for copper. This problem is common with copper, just like error and collision. By the time of light technology, a lot of things have been solved. Okay, you must match. If this port of the router was configured for full duplex, you must make sure that this port is also configured for full duplex, so that these two ports can communicate or talk to each other. Okay, speed also, we have said some generations had 10, 100 or 1000 megabit per second of, it's always like this, it's always megabit per second, okay, of transmission speed. okay, transferring speed. So in case one of them was configured to be 100, the opposite must be 100 as well, so that these two can communicate. Okay, these are some of the common errors that you might face in your network. Lastly, for this course, for this lecture, I'm sorry, we have, let's change the color. Okay, we have the network languages. Okay, there are 3 languages transporting or traveling inside the networking world. We have to know the 3 of them because we will use them all in everything in our networking world. Okay, the first type is the binary language we have talked about when we explained how cables do send data, or information. The binary language, which contains of only 2 digits, what is called zeros and ones. Okay, everything is binary in here. Each digit sent has the size of 1 bit. So when we send using a copper cable, we send 8 digits. How many are these? I always misquote them. Okay, 8 digits. You have to know that these 8 digits have the size of 8 bits. This is the first thing. And the second thing, these 8 digits traveling through a layer 1 physical connection can be either ones or zeros, nothing third. Okay, this is the first language. Zeros are low electric pulse, low frequency light wave. We have talked about this in the cabling chapters. Ones are high electrical pulse or high frequency light wave. This is the first type, the first language in networking. The second language, called the decimal, which contains of 10 digits. This is something that we understand. It's better for us to know the value of a number. It is some numbers from 0 to 9 only, but it can be represented in a single octave. We will talk about this in the future, from the 0 to 25 number. This is something we will talk about in IP addresses. Okay, the values. Okay, there is no number 10. Whenever you see this, this is 1 and 0. There is no number 10 in here. This is for us to be able to read it. What do you mean by this, by humans? Let us talk a bit further. We can read number 4 or number 9 or number 15 or whatever number that we want, okay, by ourselves. Computers don't transmit this and don't understand these numbers. They only understand the binary language. Computers and network devices only understand zeros and ones. So in order for me, or when I type number 4 in any application in my computer or in any command in the networking device like routers, switches, access points, or even firewalls, how do this specific device understand it? This happens by changing or converting this decimal number to a binary number that contains of either zeros and ones, because it only understands zeros and ones. Devices only understands binary languages. Okay, how to do that? Let us start the conversion process. Go back to the mic. Okay, this has happened by using the multiplication of number 1 by 2, etc., from right to left. So the first rule is you have number 1, multiply it by 2, the result is 2, multiply it by 2, the result will become 4, again multiply it, it will be 8, and then 16, and then 32, 64, 128, and etc. It can even become 256, 512, 1024, and it goes on as long as you are multiplying by 2. How do I make use of this chart? Just do this in front of you. How many numbers are these? 1, 2, 3, 4, 5, 6, 7, 8. This is the first one. Okay, the first thing that we are gonna do, imagine you have a number, okay, like number 10, and you want to know how to express this number, how to express number 10 for a computer device in the binary language. So we need to convert number 10, this decimal number that we understand, to the decimal language. We can do this using these numbers, okay? First of all, as a mathematical rule or a mathematical concept, how can we generate number 10 using some of these numbers? Maybe one or all of these numbers. Like, we can maybe combine 1 and 2, the result will be 3. 3 plus 4 will be 7. That is not something accurate, because if I have 1 plus 2 plus 4 equals 7, I would need 3 plus 3 to reach 10, and there is no number 3 in here. Okay, so delete this. Another concept or another method to use, maybe number 1, leave it. Number 2, if I combine number 2 and 4, okay, alone, it will become 6, so I would need number 4 again to be 8, but I have already used it, so this is also makes no use. Let me delete it. Okay, then maybe combining 2 and 8 will result in the 10 that I want. Okay, so I have made use of 2 and 8 to get number 10. The numbers that I have made use of are expressed as ones, and the numbers I did not make use of are expressed as zeros. This is 0, this is 0. By default, the entire package can be expressed in a matter of 8 digits. That's why I have write it from 1 to 128, because these are 8 numbers. 1, 2, 4, 8, 16, 32, 64, and 128. Okay, so this is how 0, 0, 0, 0, 1, 0, 1, 0. This is how you make a computer understand the number 10. Okay, let's take another example. Good. Another example, maybe another number will be like 40. How do we express number 40 in the binary language? Number 40, the most corresponding number to 40 here is like 32. Okay, let's make use of 32 plus, what do we need more to combine with 32 to obtain 40? If you did not catch it this very well, so just minus 40 from 32, we will have 8, so we will need to combine some numbers to generate 8, but 8 is already there, so 32 plus 8 will be 40. I have made use of 32, I have made use of 8, let's keep ones, and here we did not make use of them, so it will be zeros. Okay, so this is how express number 40, 0, 0, 10, 10, 0, 0. And this way we express number 40 to the binary system. Good. This is another one. Okay, let's take one larger number, even more, as a final method, or let's take it in vice versa. Let us like have randomly like 1, 1, 1, 0, 0, 0, 1, 0. Let's convert this number to a decimal number. This will be vice versa. So re-express the numbers of conversion to reconvert it, like this is 1 multiplied by 2, 16, 32, 64, 128. Now let's convert it. What did we say about the rule previously? We said that whenever I find 1, then I have made use of this number. Whenever I found 0, then this number I haven't used in the conversion. So here I have made use of this number. I have used 2, 32, 64, 128. By combining them, we will get 128 with 64 will be 192 plus 32 or 34 for directly 34, and will be 6, 3 and 9. How much will be 3 and 9? I have forgot. Maybe they are 200, and it's like 30 and 120, or 30 and 120 is like 226. So when you face 1, 1, 1, 0, 0, 0, 1, 0, and you want to know what number is this, which number is this, then this is 226. So this is the main method, the simple method of converting decimal numbers to binary numbers. Okay, so let's erase all of this and back to our slides to finish this. Okay. The last type is the hexadecimal language. We have talked about the first two. Hexadecimal language has came by using 16 digits, which are like the decimal from 0 to 9, alongside with some letters, okay, for more values and to express more or bigger values. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, and then C, D, E, and F. What you need to know is this column 4, 5, 6, 7, 8, 9. A equals 10 in value, B equals 11, C equals 12, and D equals 13, and this is, in case you were wondering, how much they equal in value. Okay, this is the language that has 16 digits, and we will see in the upcoming technologies where do we use this language. Okay, thank you for watching.